All right, so I believe this is recording. Let's take a look at these two problems. They are absolute value inequalities. Um, each problem, the first thing that we're going to do is isolate the absolute value. So in the left here on problem number 9, I'm going to add positive 2 to each side of this equation. If I do that, I get negative 3 times the absolute value of 6x plus 2 is greater than or equal to. When I add a positive 2 here, I'll get a negative 84. If I divide both to get the absolute value by itself, I want to divide both sides by a negative 3. When we multiply or divide by a negative number, we have to remember to change the direction of the arrow. And negative divided by negative is positive, and 84 divided by 3 is 28 if I key that in the calculator correctly. So now the arrow is pointing towards the absolute value. So I change the sign of 28 to negative 28 is less than or equal to. I drop the absolute values, 6x plus 2 and less than or equal to 28. This is each one of these absolute values, we write it as a compound inequality. Here we're going to shade the middle portion of the number line. It's going to be an and not an or. And when a lot of times when we have this type of compound inequality, we'll have to split it into two inequalities to solve for it, especially when we have variables in all three places. But when we only have the variable in the middle, very easy to just go ahead and balance this without writing it into two separate inequalities. If I subtract 2 everywhere, I have negative 30. The 2 minus 2 is 0. And don't forget to subtract 2 on the right-hand side here. 28 minus 2 is 26. Now I'll divide everybody by a positive 6. On the left here, I get negative 5 is less than or equal to 6 divided by 6 is 1. And 26 divided by 6, well, 6 doesn't divide 26, but I can reduce that fraction. Those are both even numbers, and I can write it half of 26 is 13 and half of 6 is 3. So I can make a sketch on the number line to see if it does fit what I was expecting, being the middle portion that's shaded. So from negative 5, 13 divided by 3 is an improper fraction. I know that 12 divided by 3 is 4, and 13 divided by 3 is going to be a little bit bigger than 4. I have to make a decision whether to include or exclude these endpoints. I'm going to shade each one of these because it's not a strict inequality. It's not strictly less than. It's less than or equal to. So these are shaded. And the solution set, like we said before, it's the middle portion of this. So if we write this using interval notation, we use brackets since we're including the endpoints. The smaller number is written to the left. It's smaller number, comma, larger number. I'm going to leave the number as an improper fraction. That's fine. So now I'm going to come over and take a look now at number 10. We want to, again, isolate the absolute value. We're going to add 7 to both sides of this equation. So 23 plus 7 is 30. We're going to divide both sides of this equation by a positive 5. So we have 5x minus 1 is strictly less than 30 divided by 5 is 6. This is similar to the last problem. The arrow is pointing towards the absolute value. So we've got negative 6 is less than 5x minus 1, less than 6. We want to get the x in the middle by itself. We add 1 to all three sections. So we've got negative 5 is less than 5x, which is less than, if I add 1 over here, I've got 7. If everybody gets divided by 5, and since it's being divided by a positive 5, the arrows will not change direction. Remember, the arrows in a compound inequality will point in the same direction, and they'll point to the smaller value. If I divide by positive 5, I get negative 1 is less than x, which is less than this improper fraction of 7 over 5. If I make a quick sketch of that on the number line, negative 1, positive 7 over 5 is somewhere to the right. So the decision whether to include the endpoints or not is made for us when we see in the original problem that the arrow doesn't contain equality, that was a strict inequality. We're not going to shade those in. With the arrow pointing towards the absolute values, we knew that we would end up shading the middle portion of the number line and not the outer tails. To write this in interval notation, since we're excluding the endpoints, we use parentheses and not brackets. So here's our final answer. And so, hey, I hope that helps, and I will talk to you later. Bye.